Okay, we're going to be doing the second part of the pre-notes to functions and relations. So we already did most of this handout, this page of notes yesterday. We learned what a coordinate was. We learned how to graph a coordinate, well, reviewed how to graph a coordinate. So down here on this example, we have the coordinate 5, 6, and you start at the origin. 5 is the first number here, that's the x value. So go to 5 on the x value, on the x-axis, on the x number line. And then 6 is the y value. So y is up and down, so go up 6. So there's a location 5, 6. I hope we remember this. We also have this thing that we did yesterday, right? All these different coordinates. So hopefully remember, like this one right here, to get to point A, you go 2 on the x, 7 on the y. So A is 2, 7. To get to point B, negative 4 on the x, positive 6 on the y. So I hope we remember that from yesterday. And now we're going to jump into today's part of the lesson, which is equations with two variables. So for the first time in this class, we'll have equations with two variables, not just one variable. Let's compare the old one variable equations with the new two variable equations. So this is what we were used to just last week. We had a test on solving equations. It is x plus 3 equals 5, right? And we know how to solve by subtracting 3 and subtracting 3, and we get the answer, right? There's only one answer here. That answer is x equals 2. And we usually write the answer as x equals 2, right? So yes, 2 plus 3 equals 5. That's the only number that you could plug in right here that'll give you a true statement. So 2 is the only answer. You can't plug in negative 2. You can't plug in positive any. It has to be 2. Now, how about a two variable equation? You have something plus something equals 5. Well, that's a different story, right? Because the x value could be 2 and the y value could be 3. Okay, so how would I write that answer? It could be like x equals 2 and y equals 3. 2 plus 3 is 5. That is a true statement, which means that x equals 2 and y equals 3 are answers to this equation. Or maybe it's not 2 and 3. Maybe it's 1 and 4, right? 1 plus 4 also equals 5. That's also an answer. Or it could be backwards. Instead of 1 and 4, it could also be 4 and 1, 4 plus 1. Or it could be 6 and negative 1, right? 6 plus negative 1 equals 5. Or it could be 7 and negative 2, which would also equal 5. Or it could be 10 and negative 5, right? That could also equal 5. Or it could be 100 and negative 95. That could also equal 5. I hope we see the idea here that there's an infinite amount of answers, okay? Now, before we even get to the infinite amount of answers, let's just take a look at these answers, like x equals 2 and y equals 3. Instead of writing x equals 2 and y equals 3, we know that coordinates are a pair of numbers in parentheses, and the first number is your x value. So x equals 2, you could just write 2, comma, and y equals 3, 3. This ordered pair is telling us x equals 2 and y equals 3. 2, comma 3 means your x value is 2, your y value is equal to 3. And instead of like 1 and 4, x equals 1 and y equals 4, you could write it as a coordinate, 1, 4. Instead of 6 and negative 1, you could write it 6, negative 1. Okay? So the question now becomes, how could you represent all the solutions to this equation? The answer? By graphing the coordinates on the xy plane and drawing a line through them. Okay? It would be nice to actually show that graph, x plus y equals 5. Let me do that. Give me 1 second. So let's actually graph the x equals 2, y equals 3 right here on the side. Now you guys don't have this on your page of notes, so just watch this video right here, or this part of the video. So let's graph x equals 2, y equals 3 as a coordinate 2, 3. So when I do go to 2 on the x, from the origin, 2 on the x, 3 on the y, 1, 2, 3, put a dot right there, and you are at 2, 3, right? Let's go to the next coordinate. We said the next answer that we gave right here was 1 and 4. So 1 on the x, 4 on the y. So 1 on the x, 1, 2, 3, 4 on the y. Put a dot right there, okay? And then the next one was 6 and negative 1. Okay, so 6, 1, 2, 3, 4, 5, 6. You're off the graph by 1 unit, and negative 1 would be 1 unit down. It would be a dot right here. So since it's only 1 unit off, I'm going to put the dot right there. But we get the idea that the line that is going through all these points, pointing at that one perfectly like that, is right there. Okay? Now, this line actually represents the infinite amount of answers that exist to this equation, x plus y equals 5. Okay? Now, what do I mean by that? Like, you see how this arrow is going up this way? It would get to that coordinate right there. And if I did get to that coordinate right there, that would imply this is the location 0, 5. So 0 for x, I'll even write that down, 0 for x, 5 for y. That is also a solution to x plus y equals 5. 0 for the x, 5 for the y. 0 plus 5, it really does equal 5. Okay. Now what if I kept going to the next dot up here, right? That would be the coordinate -1, 6, right? If I wanted to, I could put that dot right there. That's a coordinate -1, 6. That's ugly, I apologize. But anyways, x being -1 and y being 6, -1 plus 6, that is 5. That's also a solution. So all of these points, right? All of these points, all these coordinates, that coordinate right there, which is 3, 2, that also equals 5 if you add them together. This coordinate right here, which is 4, 1, that also equals 5 if you add them together. This coordinate right here, which is 5, 0, that also equals 5 if you add them together. I mean, and there's an infinite amount of answers. We even said, like, if we went to, let's say x was 100 and y was -95, that will also give you 5, right? So the coordinate 100, comma, -95, that's also on this line. Now you'd have to have some imagination that you go 100 way out here off the graph and then -95 way down there, and you're going to see that it lands perfectly on that line. Okay, but I hope we start understanding that by graphing coordinates and then drawing a line through it and putting arrows on it, we have a line that technically represents the infinite amount of answers that exist to this two-variable equation. Okay. Now this may be a lot for you to take in right now. You may have to watch this video a couple of times for it to make more sense. But anyhow, we don't need like 5 different answers. All you really need is 2 points. And I recommend going for 3 points. That way all the 3 points do line up and you get a straight line, and then you're confident about your answers. So let's actually go down here. And let's think of possible answers for this equation. Give me a number, take away another number that equals 2. All right. So we could say, like, for example, the first thing that comes to my mind is, let's say the x value is 3 and the y value is 1. Okay. So instead of me writing x equals 3 and y equals 1, I write it as a ordered pair. X equals 3, y equals 1. And why did I write that number down? Because 3 minus 1, that does equal 2. Okay. What other numbers are there? I don't know. I mean, you don't even have to think about it. You could just write any number you want for the x value. Like if I say 4, well, if I do have a 4 for my x, 4 take away what will give me 2? 4 take away 2. So for the x value of 4, I need a 2 right here that I need to subtract from to get the 2. So 4, 2 is a solution to this problem, right? You don't have to, do numbers in order. You could do any numbers, but of course you want to plug in numbers that are within this xy plane, because like if you plug in 10, well, yeah, 10 take away 8 is 2, but then you'd have the coordinate 10 taking away 8. So that would be way off this graph and way up here somewhere, right? So I wouldn't recommend using values that are not on this graph. So maybe you want to do like the number 2, right? What if I did use the number 2 for my x? 2, well, 2 minus what is equal to 2? Oh, 2 minus 0 stays 2. So my y value is 0. My x value is 2. So we have a bunch of coordinates already. All you really need is 2 points to draw a line. But let me actually just show you how all of these points will land on the line. So let's go for the first point, 3, 1. That would be 3 on the x, 1 on the y. Let's put a dot right there. Okay. Let's move to the next coordinate, 4, 2, 4, 2, 4 on the x, 2 on the y, put a dot right there. Okay. How about 10, 8? 10, you're off the graph, 8, you're off the graph, but it will be somewhere up here that lands perfectly on that line. Okay, but let's do 2, 0. Well, where's 2 on the x, 0 on the y? 2 on the x, 0 on the y. There it is. So as you could see, we do have a line going through these 3 points. Put an arrow, and you're done. Now you could extend this line by thinking of how much it's actually rising and running. It's going up 1 over 1, up 1 over 1, and you could even keep going up 1 over 1 to get to that next point right there. And yeah, technically that's slope, but we're not even talking about slope. I'm just wanting you to understand the pattern from one point to the other. You could even go backwards. Instead of going up 1 over 1, you could go backwards, over 1, down 1, over 1, down 1, and put a dot. And you could make this line as long as you want. Dot right there, okay, all these dots. But you got to use that pattern of, instead of up 1 over 1, backwards, over 1, down 1, over 1, down 1, over 1, down 1, over 1, down 1. And we end up with this, this long line, okay? Okay, and we only used, in reality, 3 points. You only really need 2. I recommend 3 so you can make sure that they line up so you'll feel more confident about your graph. Anyway, this line right here represents the infinite amount of answers, right? There's an infinite amount of answers. What do I mean by this? Well, yeah, it could be 3 and 1, or it could be 4 and 2. 4 take away 2 is 2. It could be 5 and 3. 5 take away 3 is 2. So 5 and 3. Oh, there's that point right there, 5, 3. Okay, it could be 100 take away 98. That'll also give you 2. So 100 way off the graph, 98 way off the graph. It will be perfectly on that line. This line really does represent the infinite amount of answers. Okay. Now, for example, what if your x value was 0? So if you had a 0 right here, what would this number, the y value, have to be in order for it to be a positive 2? 0 minus, this would have to be a negative 2. 0 minus a negative 2 would give you the positive 2. So that'd have to be a negative 2. And if you look at that coordinate, 0 on the x, negative 2 on the y, there it is. This line truly does represent every single answer that could possibly exist for this 2-variable equation. All right, let's flip this paper over and continue. And over here on the back top left, it says, why do we graph? So why do we graph? In reality, we graph that line and we put arrows on that line to represent the infinite solutions that exist to an equation. Okay. Is there a more organized way of graphing than just thinking of numbers that work? Absolutely, yes. Below are the steps that you could follow. Okay, so steps to graphing a 2-variable equation. Step 1. Rewrite it in function form. So we need to first know what function form actually means. This is very important, all right? Function form, it means to get y by itself. You're going to be solving for y. Okay, so make sure y is by itself. Okay, so if we actually looked at the graph that we just did, this equation is not in function form. That's why it was so challenging for us to start thinking of like what number 3, you know. So if we put this in function form, again, function form is getting y by itself. So in other words, solve for y. So check this out. I am going to identify that y is on the left side of the equal sign. It's not by itself. It has a minus sign in front of it, and it also has an x. I don't want this x. I want to get y by itself. I want to solve for y. So I want to get rid of this x. How? By subtracting x. It'll cancel out. What I do to one side, I do to the other side, okay? So what do I have left? I have a new equation that reads negative y, and then this right here, the negative x and the 2, I mean, it's 2 minus x. You can't really combine that, and I'm not going to write it as 2 minus x. Okay, what I'm going to do is write my equal sign, right there, and then instead of 2 minus x, I'm going to write negative x plus 2. Negative x plus 2, okay? Now, it's almost in function form. I almost have y by itself. All I need to do now is get rid of this negative sign, either by multiplying everything by -1 or dividing everything by -1. But the bottom line is all the signs are going to change. So change it, change it to a negative. So your new equation becomes y equals positive x minus 2. And this is your equation in function form. And now that it's in function form, now we can move on to the next steps over here. So it says, rewrite it in function form, solve for y. We already did that. We got y by itself, y equals x minus 2. Number 2, make an input-output table, an xy table. Okay, and then it says plug in 3 easy numbers, most of the time 0, 1, and 2. So what does an input-output table look like? We might as well, let's put that on pause for a little bit. Let's zoom in right here, and I purposely left space for you to draw something right here. And let's actually do that right now. An input-output table, that is an xy table, and we want to plug in 3 easy numbers for x, okay? And it says most of the time, plug in 0, 1, and 2. So 0, 1, and 2, okay? And you plug in the x values, and you pull out your y values. So let's actually do step 2 on the graph that we just did on the other side of the page. So if I jump to an input-output table, I'll do that, let's say, I'll do it right here, even though it's on the graph, I apologize. X, Y. Okay, so I want to plug in some numbers. Most of the time 0, 1, and 2 work out great. Okay, so when I plug in 0 right in there into the x, it's now easy to do. 0 minus 2. What's 0 minus 2? 0 minus 2 is negative 2. So we get out a negative 2. And that is a coordinate. The coordinate 0, negative 2. 0, negative 2. That's the dot right there. Okay, I'm going to put it in black just so you could see it. And then plug in a 1 right there. 1 take away 2 is negative 1, which is a coordinate. 1, negative 1. That's that dot. I'm going to put that dot right there. And last but not least, 2, plug in 2 for x. 2 take away 2 is 0. So this is a coordinate 2, 0. 2, 0. That's right there. So we got those 3 dots pretty easy once it's in function form. You see, a function is kind of like a machine. For each input, there's exactly 1 output. So once you get the y by itself, it's really easy to just plug in numbers for x, do the math, and then you get your answer for y. Okay? So that's what I'm recommending. These are the steps. Instead of just randomly thinking what number could x be, what number could y be, we're going to get y by itself. We're going to rewrite it in function form, solve for y. After that, make an input-output table. Maybe we should draw this with a little cloud, because this is what you need to know in your head for step 2, making an input-output table. Plug in your 3 easy numbers, most of the time 0, 1, and 2. We'll go through some that we could use different numbers. Technically, you could use any numbers you want, but most of the time 0, 1, and 2 work out beautifully. And then step 3, draw your line through your 3 points with arrows, and you're done. Okay? So if we take a look at number 1 down here, we want to practice. As you can see, y is already by itself. So it's already in function form. So you're just going to jump right in to making an xy table and plugging in 3 easy numbers, right? Most of the time 0, 1, and 2. Okay, so if I do plug in 0 right there, 0 take away 2, what's 0 take away 2? It's negative 2. That is a coordinate. Go ahead and go from the origin 0 on the x, negative 2 on the y, put a dot right there. Then we move on to the next one. Let's plug in the number 1 right into the x. Remember, these are all my x's. Plug it in, do your math. You're going to have a y answer. You're going to put it on that side. So plug in a 1 right there. 1 take away 2, that is negative 1. So 1 plugged in right there. 1 take away 2 is negative 1. Y equals negative 1. That's why you put a negative 1 for the y's. Okay. Last but not least, oh, let me graph that. I'm sorry. 1 on the x, negative 1 on the y. 1 on the x, negative 1 on the y. Put a dot right there. And last but not least, 2, what? Plug in a 2. 2 take away 2 is 0. Okay? So 2, 0, 2 on the x, 0 on the y. There it is. Put a dot right there. And here is our line. Okay? All you got to do is draw your line and put some arrows on it, and you're good to go. Now, if you wanted to extend this line further, you could just compare the pattern from one point to the other. It was up 1 over 1, up 1 over 1. You could put a dot there, there, and there. Likewise, over 1, down this one, put a dot, or over 1, down 1 this way, put a dot there, there, and there, and you could extend it as long as you want. But those arrows already take care of it because it does go both sides forever. All right, so let's move on to the next one. So moving on to number 2 here, y is not by itself. We need to get it in function form first. Okay, so we need to solve for y. How do we get rid of this 2 that's in front of the y? That's really saying 2 times y. So how do we get rid of that multiplication of 2 in front of the y? We're going to do the opposite, the inverse operation, which is dividing by 2. And when you do to one side of the equation, you do to the other side, and I'm talking about the entire side. So what do we have left? We have y equals 4 divided by 2 is 2, but we do have an x. And right here, 2 divided by 2 is 1, and there's a minus sign in front of it. So there is our function form equation, y equals 2x minus 1. Now after that, it's really easy, once you have it in function form, to create an xy table and plug in 3 easy numbers, most of the time 0, 1, and 2. 0, 1, and 2. It's really easy to plug in 0. 2 times 0 is 0, and 0 minus 1 is minus 1. And of course, you might want to show your work, so you would write like 2 times 0 minus 1. That'll be 0 minus 1, which equals negative 1, okay? I'm just going to do this work in my head right here. Plug in a 1 into x, because after all, these numbers are on the x column. So plug in 1 into x. 2 times 1 is 2. 2 minus 1 is 1. Okay, so we put a 1 right here. Last but not least, plug in a 2 right there. What's 2 times 2? That's 4. What is 4 take away 1? The answer is 3. Okay, so we have these 3 coordinates, 0, negative 1, 1, 1, and 2, 3. Let's graph 0, negative 1. 0 on the x, you don't go left, you don't go right, 0 on the x, negative 1 on the y. There it is, put a dot right there. Next one, 1, 1. 1 on the x, 1 on the y, put a dot right there. And the last one, 2, 3. 2 on the x, 1, 2, 3 on the y, put a dot right there. So there is our line, okay? Put arrows on it and you're done. So again, the main idea that we want to acquire here is that we want to get it in function form first. What does that mean? Get y by itself, and then make your xy table, plug in some easy numbers for x, plug them in right there, do the math, and you'll get your answers for y. So plug in 0, get out of negative 1. Plug in 1, get out of 1. Plug in a 2, get out of 3. So let's look at number 3 down here. It's not in function form. You want to get it in function form by getting y by itself. So you don't want this negative 2 and you don't want this 6x. So what should we get rid of first, the negative 2 or the 6x? Let's get rid of the 6x. After all, what's important here is y. You want y by itself. That's what's important. The 2 or the negative 2 is with the y. So wait to get rid of that till later. Get rid of this value that's all by itself. So let's get rid of that 6x by subtracting 6x. What you do to one side, do to the other side, subtract 6x. Now, we know that 6x take away 6x is 0. There are no more x's. So what do I have left on the left side? I have a negative 2y, an equal sign. Now, we also know that we can't subtract x's from numbers. So 4 take away 6x, you can't do it. So you could rewrite it, 4 take away 6x. But whenever you have numbers and letters, it's better to write the lettered term first. The negative 6, let's write that first, negative 6x. And afterwards, put the positive 4 right next to it. So put plus 4 right next to it. Last but not least, I want to get y by itself. I want to get rid of that multiplication of negative 2 in front of the y. You get rid of multiplication by dividing. So divide by negative 2, divide by negative 2, divide by negative 2. And what do we have left? We have our new equation that reads y equals a negative 6 divided by a negative 2. That is a positive 3. We have an x right next to it. And last but not least, 4 divided by negative 2. That is a negative 2. So here is our function form equation. We now have y by itself, and we now are able to make an xy table and plug in values, 3 easy numbers that are easy to work with. Most of the time, 0, 1, and 2. So if we do plug in a 0 into the x, 3 times 0, right? 3 times 0 is 0, and 0 minus 2 is negative 2. So when I plug in 0, I get out a negative 2. When I plug in a 1, 3 times 1 is 3. 3 minus 2 is 1. And when I plug in a 2 right there, 3 times 2 is 6, and 6 minus 2 is 4. So we have these coordinates, 0, negative 2. That's 0 on the x, negative 2 on the y. Put a dot right there. Let's go to the next coordinate, 1, 1. 1 on the x, 1 on the y. Put a dot right there. Let's go to the last one, 2, 4. 2 on the x, 2 on the x. 1, 2, 3, 4 on the y. Put a dot right there. And you only need 2 dots for a line, but as you can see, we do 3. That way we could be really comfortable when we see that all 3 dots line up. Okay. Number 4, it's almost in function form. I almost have y by itself. All I need to do is get rid of that plus 5. So I'm going to get rid of it by subtracting 5. And what I do to one side, I do to the other side, subtract 5. So of course this cancels out. What do I have left? I have a nice beautiful y all by itself. That's what function form is, getting y by itself, solving for y. What does y equal? Well, we can't really subtract 3x, take away 5. You can't combine those, so let's just rewrite it. And of course, we want the x term first, 3x, and the minus 5 second. Anyway, this is now in function form, y is by itself, and now you jump into an input-output table, an xy table, and plug in 3 easy numbers like 0, 1, and 2. Okay, so when we plug in 0 right there, 3 times 0 is 0, 0 minus 5, that is a minus 5. So the input 0 gave us the output negative 5. Let's plug in 1 right there. 3 times 1 is 3, and 3 minus 5 is negative 2. Okay. And last but not least, let's plug in the number 2 right there. 3 times 2 is 6. 6 minus 5 is positive 1. 6 minus 5 is positive 1. So again, the input 0 gave us the output negative 5. The input 1 gave us the output negative 2. The input 2 gave us the output 1. Or I could have also said the x value of 0 gave us the y value of negative 5. The x value of 1 gave us the y value of negative 2. The x value of 2 gave us the y value of 1. These guys are coordinates, 0, negative 5. 0 on the x, negative 5 on the y. You'll be right there on the edge of the graph. The next coordinate, 1, negative 2. 1 on the x, negative 2 on the y is right there. Last coordinate, 2, 1. 2 on the x, 1 on the y is right there. As you could see, these 3 dots, they really do line up, if my line wasn't crooked, but they do line up. So I'm confident that that line is the correct line. Let's move on to another one. Right here, we want to get y by itself. We want to solve for y. We don't want the negative 5 in front of the y, but we definitely don't want this guy. Let's get rid of this guy first. How do I get rid of a minus 25? By doing the opposite, plus 25. What I do to one side, I do to the other, plus 25. So right here, they do eliminate. What do I have left? I have a negative 5y equaling, now I cannot combine 15 x's with the number 25. It's not like I get 40 x's when I combine these. You can't do it. Can't add numbers with x's. So I'm simply going to rewrite it. I'm going to put my x term first, my 15 x's first, and the plus 25 second. Now for my final step to get it in function form, to get the y by itself, I'm going to get rid of the multiplication of negative 5 by dividing by negative 5, dividing by negative 5, dividing by negative 5. So as you can see, that eliminates. We end up with a nice beautiful y. That's function form, getting y by itself. And right here, 15 divided by negative 5, that is a negative 3. And of course, it has an x on it. And last but not least, 25 divided by negative 5. You could use a calculator if you need it. That'll be a negative 5. So there's your function form equation. Y is by itself. And we call it function form. A function is like a machine. It's really easy to put in inputs and pull out outputs. The inputs are the x values, the outputs are the y values. So we're going to plug in 3 easy numbers like 0, 1, and 2. So when you do plug in 0 right there, anything times 0 is 0, and 0 minus 5 is minus 5, or negative 5. Plug in a 1 right there, you're going to have a negative 3 times 1. That's going to be a negative 3, and then negative 3 minus 5. Negative 3 minus 5 is negative 8. And then plug in a 2. 2 right there is negative 3 times 2 is negative 6. Negative 6 minus 5 is negative 11. Now, check out what happens when we graph these coordinates. 0, negative 5, 0, negative 5 is right here. Now, if I go to the coordinate 1, negative 8, 1, negative 8, that's going to be off the graph. I mean, I could put the dot at 2 units off the graph, but that's really not good. Now, even if I went to 2, negative 11, 2, negative 11, it's way down here. I mean, yeah, it lines up, but we don't want the line coming way off the graph. So maybe instead of plugging in 0, which the input 0 gave us the output negative 5, the input 1 gave us the output 8. Maybe instead of plugging in 1 or 2, how about we plug in the input negative 1? And it's going to give us a dot somewhere right here. So you could actually do that, negative 1. When you do plug in a negative 1 right there, what's negative 3 times negative 1? That's positive 3. Positive 3 minus 5, that will be a negative 2. So negative 1, negative 2 is a coordinate, which is right there. And as you can see, it does line up. This one would have lined up, but it's off the graph. So yeah, anyway. So, and you could plug in more points. So like I said, most of the time we use the inputs 0, 1, and 2. But sometimes we have to use other inputs. In this case, the inputs went, or the coordinates that we got using 0, 1, and 2 ended up with points off the graph. So we use different inputs. Last but not least, and notice right here on these instructions, it says 0, 1, and 2 are not the best x values. We'll see why right now. We want to get y by itself. We want it in function form. We don't want this multiplication of 2 in front of the y. So we're going to divide by 2, divide by 2, divide by 2. That will give us y equals, you can't really do 3 divided by 2, so let's just leave it like a fraction. 3 over 2, there's an x right there. And the last one, 8 divided by 2, that is 4. Okay, so we're going to put minus 4 at the very end. Okay, let me do that in black. So there's our function form equation. We now want an input-output table, an xy table. Now, because we have a fraction here, it would not, I mean, 0 is always great. Go ahead and use 0, because when you plug in a 0 right there, 3 halves, any fraction times 0, it's going to be 0, right? 3 times 0 is 0. 0 divided by 2 is still 0. And 0 minus 4 is negative 4. Okay. Let's plug in, if I did plug in a 1, think about that. 3 halves times 1 is 3 halves. You have a fraction. Then a fraction take away 4, you're going to get more fractions. And graphing with fractions is definitely not fun. So we're not going to use 1. You see, whenever you do have a fraction in front of x, I recommend using the denominator and maybe double the denominator, okay? Or maybe the denominator but negative when you plug it in. So instead of plugging in 1, which usually is really easy, let's actually plug in the denominator 2. Okay. When I plug in a 2 right there, let me actually write it out and show you. I have 3 halves times this 2 times 2, and then we have minus 4. Okay. What happens when you multiply 2 with the 3 halves? The 2's cancel out, and 3 take away 4 is negative 1. So when you plug in a 2, you get out a negative 1. So that's a coordinate. So let's go to these two coordinates. 0, negative 4. 0 on the x, negative 4 on the y. There it is. So let's put a dot right there. And let's go to the coordinate 2, negative 1. 2 on the x, negative 1 on the y. Put a dot right there. And ladies and gentlemen, that is our line going through those 2 points. Put arrows on it and you're done. Of course, you could plug in more inputs to find more outputs, to make more coordinates. Now, like I said, whenever you do have a fraction, it's good to use that denominator. Maybe double the denominator, which would be a 4. Let's try plugging in 4. What am I saying? Plug in 4 right there, and let me actually show that math for you. That's 3 halves times 4. Again, I'm inputting 4, and then minus 4. Okay, well, how do you multiply a fraction times a number? You can put that number over 1 and multiply top with the top. 3 times 4 is 12. Bottom with the bottom, 2 times 1 is 2. So you really have 12 over 2. 12 over 2 is really 6. And then 6 minus 4 will give you the final answer, 2. So when you do plug in a 4, you get out a 2. And where's that coordinate? 1, 2, 3, 4, 1, 2. That'd be a dot right there. And that does line up perfectly on that graph, on that line. Anyway, I think this video is way too long already. But just to finish it off, as we could see, an XY table is a way to keep track of those numbers that we plugged in and got out. We plug in our numbers into the x values, then we do the math, and we get out our answers, which are our y values. Okay, this is why on section 6.1 and 6.7, we know that x values are the inputs and the y values are the outputs. Let me repeat that one more time. The x values are the numbers that you put in. That's why they're called inputs. And the y values are the answers that you get out. That's why they're called the outputs. I'm done. See you later.